Hello Calculus. It's November the 8th after class, and you can watch this on November the 8th or the 9th, whatever works best in your schedule. I'm going to teach a new topic tonight, and I'm going to start with a definition that will help along the way, but I'm not going to tell you what I'm defining. I'm just going to define it and see if you can tell me what it is. It says, write this down, two blanks. x1 and x2 are two numbers, and in an interval, whenever x1 is less than x2, then f of x1 must be less than f of x2. What have I defined? So I have presented this enigma to previous calculus classes, and even the top guns in those classes weren't able to tell me what this was. And yet it is a straightforward math lingo definition, which I think you can tell me what it is. So think about it, write down what you think I have described, and I'll talk about it a little more with a picture. It says x1 is less than x2, so therefore on the number line, the x-axis, then x1 will be on this side of x2. So if that happens, then the function evaluated at x1, so I'm going to go up and hit a function, is going to be less than f of x2. So therefore, what do we have? What kind of function is described here? And I'm not sure if you could picture it, but it is an increasing function. Increasing function. So that's the definition that I wanted to start with. Let's go on and then define decreasing function. And that is if x1 and x2 are two numbers, in an interval if x1 is greater than x2, then, it's going to be the same. If x1 is less than x2, it's going to be the same, then, but the conclusion is different, then f of x1 is greater than f of x2. So we have sort of the opposite thing happening. When x1 is less than x2, that's showing up, then f of x1 is greater than, I'll move this up, f of x1 is greater than f of x2. So we have a decreasing function. Alright, so I'm hearing a very strange noise at my house, so I'm going to check on it. So this is a short section. We'll be back for part 2. But get this down and we'll be ready to go. So come right back.